Hi and welcome to MSc. In this video we're going to be looking at angles in standard position and reference angles. So when we consider a rectangular plane or the Cartesian plane, we can actually place angles right on this plane. They don't have to be inside geometric shapes like triangles. And in doing so we define an initial arm, and this initial arm is always along the positive x-axis as it's drawn in this case here. And we also define a terminal arm, which can be in any of the four quadrants located around our Cartesian plane. And while we still refer to these as x and y, we have now defined an angle, which I will call theta, that always goes counterclockwise from the initial arm around to the terminal arm. This is generally called theta. It could also be called alpha or some other variable. That is an angle in standard position from the positive x-axis going counterclockwise to wherever that terminal arm lies. In doing so, we've also created a reference angle, which we typically call phi. Again, other names like beta can be used. It doesn't really matter what we call it. I will work through calling the angle in standard position theta, and the reference angle I will call phi. This reference angle is generally denoted as a positive angle, even if our calculator sometimes will give us eventually, once we start calculating them, negative values. We'll just treat it as a positive. And so it is always the angle formed between the terminal arm and the x-axis. Identifying theta and phi is a key essential first step in figuring out how to work with angles in standard position. So here's another example. I have an angle drawn out and I'm asked to label the angle in standard position. And we have to remember how it's defined. The angle in standard position is always starting from the initial arm, which is always the positive x-axis, working counterclockwise around to wherever that terminal arm might be. So this is my theta. That is my angle in standard position. My reference angle is always the angle that the terminal arm makes with the x-axis, not the y-axis here, even though it's closer, it's always with the x-axis. So this is my phi, that is my reference angle. There is a relationship between these two, and I'll cover that in a later video, and you should check that out. So here's four examples. And so we have a angle in standard position here, theta, and we have the reference angle phi. Now you'll notice here that this is quadrant 1 that we're working in. And in quadrant 1, we can say that theta equals phi. They will always be the same in quadrant 1. In quadrant 2, we have our angle in standard position from the positive x-axis around. And now I have my phi value. That's this one. And what we can say here, to calculate phi, we can say that phi is going to equal 180 minus theta. That'll give me the size of the phi value. Or I could say that theta is equal to 180 minus phi, right, with the rearrangement. So both of those could be useful depending on the question. When the terminal arm is around in quadrant 3, we have our angle in standard position, and we have our reference angle phi drawn here. Again, taking phi to be positive in all these scenarios, we can say here that theta is going to be 180 plus phi. Lastly, we have our angle in standard position here in quad 4, where we're going all the way around. That's my theta, and my phi value is always with respect to the x-axis. So this is my phi value here. And we can say, well, okay, so theta is going to be 360 take away phi. And that will give us the red theta value, which is the angle in standard position. So that's the key first step, being able to draw out angles in standard position and draw the correct reference angle, always with the x-axis. And the angle in standard position is always measuring counterclockwise from the positive x-axis. Hope this short video has been helpful. If it has, consider liking the video and subscribing to the station. And as always, thank you very much for listening and watching.